right, so today's lesson is really going to focus on what it means to be a solution to something. So most of this is pretty self-led, and I think that you could probably do most of it without my help. So I want you to just start by stopping the video and doing 1A, solve that equation, and then 1B, what's the solution to the equation, and then read over what C says, and then try D and E, and come on back and make sure that you did it right. So actually stop the video and do all of number 1. Tune back in when you're done to make sure you've got it. All right, so if you solved the equation correctly, you should have gotten that the solution to the equation is x equals 5, or you could just say it's 5. Now, the word solution sometimes throws people. So it's important to understand, what does it mean to be a solution to the equation? So this 5 is the answer, it's what x is, but it's also the number that you plug into the equation to make both sides of the equation true. So that's what makes both sides equal. So it's important that you understand this, because you're going to need to apply that basic understanding to other situations throughout this. All right, so to prove that it's indeed a solution, you do a check, right? So what you do is you plug it into the equation and see if it makes the equation true. And so right here is my work that it indeed does. Both sides end up equaling 17. So then we're going to throw in some stuff with number lines. It says, could you graph the solution on the equation of the equation on the number line? And the answer is yeah, right? If you have a number line, the answer is 5. You could just put a dot right there on 5. You could put it right on the number line. You could put it above the number line. But the solution, yes, indeed, does fall on the number line. All right, go ahead, stop the video, and try number 2 on your own. Answer all the questions, and then come back and make sure that you've got it right. Okay, so the answer to this equation ends up being a special solution. So I want to point out to you, I want to remind you again, that following the steps simplify, collect, isolate, check is a really good way to do this problem. When you do this, you do get that both sides equal 2x plus 3. Right here is a clue that the solution to the equation is going to be all real numbers, but I do want you to take it that extra step and show me that you can see that when you subtract 2x from both sides, the variables actually cancel out. And if you're left with a true statement, remember, that is equal to all real numbers. That means any number could fit in here, all right? Now on a number line, yeah, I could actually show this on a number line. Remember inequalities? We haven't talked about inequalities in this class yet, but you have done them before. Like if I say that the value of x is greater than or equal to -2, well then what I do is I find -2 on the number line and I shade all the values greater than or equal to it, so I would color in the -2. So if you're showing that the solution is all real numbers on a number line, all you do is you just basically shade the number line, and I usually darken my arrows in the direction that it's going. All right, what we were just talking about was solutions to one variable equations, right? Remember, solutions are what make the equation true. So now I want you to read through number 3. We're now considering the following equation that has 2 variables, saying x plus y equals 6. So now think about, what does it mean to be a solution to an equation like this with 2 different variables instead of just 1? Stop the video, answer that question, and then go ahead and see if you can finish this question, and then tune back in to see if you've got it. So try it on your own first, and then tune back in to see if you've got it. So when you have 2 variables, the solution is going to be the 2 numbers, like the x value and the y value, together when you add them have to equal 6, right? So what you're looking for when you have 2 variables, if you actually have 2 numbers, that will make the equation true, right? And so you would write your answer as an ordered pair. Remember, the first number is x and the second number is y. There has to be a comma in between it with parentheses around it. So for example, if x is 1, y would have to be 5, because 1 plus 5 will equal 6, right? So if x was 4, y would be 2, and you could represent that solution as an ordered pair 4, 2. Same with if x was 7, well, that would be 7 and -1, because 7 plus -1 equals 6. Same with if x is 30, well, it would be 30. -24 is your solution, because 30 plus -24 is 6, right? And so ordered pairs again for this next one would be 2.5, 3.5. 10, or -4, 10. And then 6, 0. All right, it's important that when you write ordered pairs that they're separated by a comma and you put parentheses around them. So then now if you think about it, if I ask you, well, how many solutions do you think will make this equation x plus y equals 6? Like how many of them will there be? Could I ever stop picking numbers for x and getting a value for y? Think about that. The answer is no, right? So like we've already found like 7 of the solutions. There's an infinite number of solutions here. So you could say infinite with the word, or you can write the infinity symbol. Either one is correct. And then these solutions can be represented on the coordinate plane by plotting points. So now taking a look at number 4, consider the following equation with 2 variables, y equals x minus 3. Think about that. How many solutions do you think it will have? Think about, you would pick a number for x, you plug it in, you could find a number for y. You could pick a number for x, plug it in, find another number for y. You could keep doing this, right? Can you ever stop picking numbers for x? Or you can even pick numbers for y and solve for x. There is an infinite number of solutions. So are you noticing a trend here? Equations with 2 variables have an infinite number of solutions. Okay? So now if I say give at least 5 examples of a solution to back up the fact that there are an infinite number of solutions, what I'm asking you to do is you're either going to write your answer using an XY table, or you can write your answer as a list of ordered pairs. Either way, but what you're doing is you're picking numbers for x or for y and then figuring out what you would need to do to get numbers to get the other value for y. So for example, when you do give me examples, you always want to give me at least one negative value for x or for y, and you want to give me a 0 for one of them, and you want to give me a positive. So typically what I do when I do problems like this is I pick values for x, right? So let's say I'm going to make an xy chart. I'm going to say, okay, well, if x is -3, -2, -1, 0, 1, and 2, I'm kind of bleeding into the next question here. If I pick those, then you just plug them in to the equation, right? So I'm saying that the value of x is -3. You plug -3 in here. When you do -3 minus 3, well, -3 minus 3 is -6. So that would mean that the value of y is -6, right? So you're just plugging it in. You could also write your answer as -3, -6, right? If I plug -2 in for x up there, you do -2 minus 3. Well, that's -5. And so you have the ordered pair, -2, -5, right? So you write your answer like this, or you could write it like this. Come up with 5. You don't have to use my 5. Then when you're done picking 5, finding 5, you need to graph them. So my advice, this graph is a 10 by 10 graph. So I would make sure that I pick numbers that fit on my graph, right? So then you're going to graph them and then tell me what you notice about those points. So stop the video, finish this problem. You can use my numbers or you can pick your own, okay? Stop the video and finish this question. All right, so no matter what solutions you ended up picking to graph, they should form a line, right? So they should all be on the same line. So right here, if you look over to the right, those are my ordered pairs that I picked, but you could have ordered pairs anywhere along this line. And so the way to show what your solution to the equation is and to show that it's infinite is you graph the ordered pairs and then you form a line. So you don't have to put all these points on here. You just have to put the 5 that you picked. But it forms a line, so you should draw the line and then put arrows at the ends of both lines. And because you have the arrows mean that the solution goes on forever in both directions. All right, so let's take a look at number 5. I'm actually only going to do number 5 and 9 with you, parts of it, and then I'm going to have you finish the rest on your own. So the next question is just saying, is the point 5, 3 a solution to y equals x minus 2? In order to do that, I'm just asking, if I plug x, 5 in for x, and 3, this is x, and 3 in for y, into the equation, will it work, right? That would be whether or not it's a solution. I do, however, expect you to show me work. So I want to see you physically put 5 in for x and 3 in for y. So I'm going to rewrite the equation y equals x minus 2 as 3, because y is 3, equals 5 minus 2. And then you just do the math, right? Over here is easy. 5 minus 2 is 3. So then you would show me, oh yes, 3 equals 3. So the answer to the question is yes, that's a solution. If you get a false statement, then no, it's not a solution. So let's jump to number 9. Number 9 is then giving you part of a coordinate, right? So this one says so I'm looking at number 9, find the missing coordinate for each ordered pair, or for the equation y equals negative 4x plus 8, right? So this one, I'm giving you part of it, and I want you to find the other one. So here, the 3 is in the x spot. So to find the y, I'm just going to plug the 3 in for the x, and this is how I want you to show your work. You're going to start by just writing, okay, I don't know y, so I'm going to say y equals negative 4 times 3 plus 8. And then you're going to do the math, right? Negative 4 plus 3, or times 3 is negative 12. So you get y equals negative 12 plus 8, and then negative 12 plus 8 is negative 4. So you get the value of y is negative 4. Now that ordered pair would be 3, negative 4. All right? Now I'm going to skip B for a second, and let's jump to C. So for C, if you take a look at C, I'm asking for x, I'm giving you y. So you're going to replace the y in the equation with 4, and you solve for x. So you're going to do 4 equals negative 4x plus 8. And now here in this case, I can't just do the math. I have to actually find the value of x. So I'm going to work backwards, right? I'm going to subtract 8 from both sides. 4 minus 8 is negative 4 equals negative 4x. And then I divide both sides by negative 4 to get x alone. And I get 1 equals x, right? So the answer to the question is x equals 1. But if I want to write that as an ordered pair, that would be the ordered pair 1, 4. All right, so that's enough information that I think that you probably need in order to finish this packet. So you can stop the video and just work on your own, but if you want to see that 6, 7, 8, and B and D are correct, you can stop the video, do those questions, tune back in, and see if they're correct. After that, you're on your own. Let me know if you have questions. All right, and so here are the answers to the rest of it. I want to just reiterate that showing your work is pretty important to me, so make sure you're paying really close attention. I know you could do that in your head, but you have to prove to me that you did it, okay? So I want to see this work here. All right, go ahead and stop the video and finish the rest of the sheet.